Welcome to the official podcast series by Potenza, where innovation meets insight. In this series, we dive deep into the world of SAP, explore the power of robotic process automation, and unlock the true potential of data analytics. Whether you're a tech enthusiast, a business leader, or just curious about the digital transformation shaping our world, you're in the right place. Tune in, stay curious, and let's explore the future of enterprise technology together. Don't forget to subscribe and follow us on YouTube for more powerful insights. Now, let's get into today's episode.
Imagine something for a second. Picture yourself holding a brand new top-of-the-line smartphone.
Oh, right. The kind that costs way too much money.
Exactly. It has all the latest features, the absolute fastest processor on the market, the sleekest interface imaginable. Now, I want you to imagine trying to plug that incredible piece of modern technology into a 1970s rotary dial telephone.
A rotary phone?
Yeah, the heavy plastic ones mounted on a kitchen wall with a huge coiled cord. Imagine wiring those two devices together and expecting them to share data seamlessly. Sounds completely impossible, doesn't it? Or at least incredibly frustrating.
Definitely frustrating.
Well, welcome to the deep dive, because that exact scenario, that massive technological culture clash, is the reality that enterprise IT teams are dealing with every single day.
It is a phenomenal analogy, honestly, because it captures the sheer friction of the situation perfectly. I mean, it sounds like a joke, but trying to get systems separated by decades of technological evolution to speak to one another is the daily reality for some of the biggest companies in the world.
And that is why today we are diving into a comprehensive guide on something called SAP Legacy Integration. Our mission for this deep dive is to figure out why massive, multi-billion-dollar organizations don't just, throw away their ancient technology. We are going to explore exactly how they manage to bridge the gap between shiny, modern SAP enterprise systems and decades-old infrastructure.
And how they pull it off without bringing everything to a screeching halt.
Right.
What's fascinating here is that we really need to define our terms right out of the gate, because not all integration is created equal.
Okay, lay it out for us.
The source material is very careful to distinguish SAP legacy integration from other types of connections. For instance, you have your standard SAP to SAP integration. That would be like connecting an older SAP system, say ECC, to a newer SAP S/4HANA system.
So they're different versions, but they speak the same fundamental language.
Right. Then you have SAP to non-SAP integration. That is linking SAP to a modern third-party platform like Salesforce or Workday.
Okay, so in that second scenario, they are different brands, but they were both built in the modern era with modern connection points.
Correct. But SAP legacy integration is its own distinct beast. This is specifically about bridging modern SAP systems to older, highly non-standard systems that completely lack modern APIs.
We're talking really old stuff here.
We are talking about connecting to mainframes from the 1980s, outdated middleware, or proprietary tools that run on vendor-specific protocols that haven't been updated in 20 years. That is the core challenge.
See, as someone looking at this from the outside, the immediate obvious question is, why not just replace it?
Right.
If these legacy systems are so incredibly old, if they predate cloud computing and modern architectures, why go through the headache of integrating them at all? Why not just rip them out by the roots and install something new?
It is the first question everyone asks, but the source makes it abundantly clear. The decision to keep legacy systems is rarely just a technical one. It is deeply strategic, and it fundamentally comes down to three things: risk, cost, and regulation.
Risk, cost, regulation.
Exactly. Wholesale replacement sounds great on a whiteboard, but in reality, it carries risks that C-suite leaders and compliance officers simply cannot stomach. Let's look at some of the high-stakes industry examples provided in the guide, starting with the banking sector.
I would imagine banks have some of the oldest tech out there. How does a legacy mainframe do something a modern cloud server can't?
Well, it's not necessarily that the modern server can't do it. It's about the regulatory burden of proving it. Core banking platforms often run on absolute behemoths of mainframes. They must maintain transaction logs in highly specific formats dictated by strict financial regulators.
Okay.
The regulators have approved that specific mainframe's method of logging. If you replace that system, you risk a compliance gap where your new logs might not meet a decades-old legal standard.
Oh, wow. So you break the law just by upgrading your tech?
Potentially, yes. Then you have the pharmaceutical industry.
Okay, let's unpack this, because in pharma, everything is strictly monitored. The guide mentions GXP-validated systems. What does that actually mean for the IT guys?
GXP is basically an umbrella term for good practice quality guidelines and regulations. In pharmaceuticals, every single digital system that touches the manufacturing or testing of a drug has to be validated. You have to prove to agencies like the FDA that the software performs exactly as expected 100% of the time with zero deviations.
It sounds intense.
It is. You cannot simply decommission one of those legacy systems and plug in a new cloud app.
Because then you have to prove to the FDA all over again that the new cloud app is perfect.
Yes, and that triggers massive, incredibly costly regulatory revalidation cycles. The documentation and testing required for recertification can take years, and the costs alone can completely dwarf whatever you originally planned to spend on the new software.
Just to get back to where you started.
Exactly. And then you have utilities. Think power grids or water management. They use legacy SCADA systems.
SCADA. I saw that acronym. Supervisory Control and Data Acquisition. But what does that actually look like in the real world?
Imagine the physical sensors on a massive municipal water pipe or the voltage regulators on a power grid. These legacy systems manage that physical, real-world infrastructure. They are hardwired into the physical world.
Oh, I see.
In many cases, there simply isn't a viable, modern, off-the-shelf software replacement that meets those highly specific physical operational requirements without completely tearing up the physical infrastructure as well.
The financial and human elements here are just staggering. The source mentions that large enterprises have often invested millions, sometimes hundreds of millions of dollars into this legacy infrastructure over the decades. It's a massive sunk cost.
Huge.
But the guide also talks about re-implementation risk,
Yeah.
which basically means if you rip out a system that handles your core revenue and there are data migration errors or process gaps or unexpected downtime during the cutover, your business stops making money instantly.
The disruption to revenue-generating operations is the ultimate nightmare scenario for a CEO.
There is a human element to this as well, what the guide calls skills dependency. I want you, listening right now, to think about a crucial process at your own job. I guarantee there's that one person in your office who knows exactly how to navigate that one quirky, ancient database.
Everyone knows that person.
Right. If they go on vacation, everyone panics. Now scale that up to a global enterprise. These old systems rely on the specialized, undocumented knowledge of long-tenured staff. If you try to replace the system before successfully transferring all that intricate knowledge, you are flying blind.
You aren't just replacing code, you are trying to replace decades of institutional muscle memory, which brings us to the actual mechanics of this.
Right. If we go back to our rotary phone analogy, even if you physically wire the rotary phone to the smartphone, they still don't speak the same language. A rotary phone uses literal clicks, and a smartphone uses digital code. How is the modern SAP system actually understanding the data coming out of a 1980s mainframe?
The guide breaks this down into 5 primary methods of integration, functioning basically as a sliding scale of complexity. The first is point-to-point integration. This is a direct hardwired connection between SAP and one specific legacy system. Enterprise architects refer to this as spaghetti integration.
Spaghetti integration. That paints a pretty vivid picture. I'm imagining just a tangled mess of cords behind a TV stand, but on a corporate level.
That is exactly what happens. It might be quick to set up for one isolated use case, but if you do this for every old system, you just have custom connection wires crisscrossing everywhere. It is messy, doesn't scale, and if one string of spaghetti breaks, you spend weeks trying to find it.
So how do you avoid this spaghetti mess? If point-to-point is too chaotic, what's the alternative?
As environments grow, you move to the second method, middleware-based integration. Think of middleware as a highly efficient central broker or a traffic cop. Instead of systems talking directly to each other, everything talks to the middleware, and the middleware writes the data where it needs to go. The source mentions tools like SAP Process Integration or Process Orchestration PIPO for on-premise, or SAP Cloud Platform Integration CPI for the cloud. There are also third-party tools like MuleSoft. The traffic cop manages the complexity so your digital footprint stays organized.
But what if the legacy system is so old it doesn't even know how to talk to the traffic cop? I mean, some of these systems predate the concept of middleware entirely.
That is where the third method comes in, API-based integration. This is where you essentially wrap your older system in a modern disguise. Developers will build a custom layer of code around the legacy system that translates its internal functions into standard web service protocols like REST or SOAP.
So it's a new translator.
Exactly. SAP's modern environments can use modern APIs to knock on the door, and the wrapper translates that knock into something the old system understands.
That makes sense for systems that need to talk constantly.
Sure.
But what if you don't need the data right this second? What if you just need a summary at the end of the day?
Then you use the fourth method, database-level integration. This relies on ETL processes. That stands for extract, transform, load.
Give me an ELI 5 on ETL. Extract, transform, load sounds like moving boxes in a warehouse.
That is actually a great way to look at it. Imagine you have a messy warehouse, your legacy database. At midnight, a crew comes in. They extract all the relevant boxes. Then they transform them, which means they repackage the contents into standardized, neatly labeled boxes. Finally, they load those new boxes into the modern, pristine SAP warehouse.
Oh, that makes total sense.
It's an overnight batch process. It's highly reliable and lower cost, making it perfect for things like end-of-month reporting, analytics, or archiving.
Okay, but let's say I'm a massive retailer. It's Black Friday. I can't wait for the midnight warehouse crew to move the inventory data. I need to know instantly if I sold out of a TV so I can update the website. How do you handle that kind of high-stakes, real-time integration?
That brings us to the fifth method, and arguably the most sophisticated, event-driven integration. This uses asynchronous messaging platforms like Apache Kafka or SAP Event Mesh.
Asynchronous messaging, does that just mean they aren't talking at the exact same time?
Exactly. Think of it like a highly reliable post office. When a transaction happens in the legacy system, say a TV is sold, it doesn't try to force a connection to the SAP system. It simply drops an event message into the Kafka post office. The SAP system checks the post office and grabs the message when it's ready. The real beauty of this is resilience. It completely decouples the systems.
So if the legacy mainframe suddenly crashes from all the Black Friday traffic, it doesn't drag the modern SAP system down with it.
Precisely. The SAP system just keeps working, and any new messages simply wait safely in the post office queue until the mainframe waits back up. It prevents cascading failures.
Here's where it gets really interesting, though. We've talked about the high-level methods, but let's look under the hood at the actual data. The guide outlines specific architectural layers that have to be built for any of these methods to work. The first one is data mapping.
Data mapping is crucial. SAP uses very standardized, rigid data structures, things called IDOCs or BAPIs. Legacy systems do not.
The text mentions legacy systems often spit out raw flat files. What does a flat file look like compared to an IDOC?
Think of a flat file like a giant, messy notepad document. It's just a wall of text with no formatting, no columns, and no labels. SAP, on the other hand, expects data perfectly organized into specific labeled folders. That's what an IDOC is. So mapping defines exactly how a random string of text in the old system corresponds to a specific field like customer ID in the SAP folder.
And once you map it, you have to actually reshape it, which brings us to the transformation layer. The integration tool has to physically manipulate that wall of text, applying business rules, changing date formats, maybe even doing math on the fly to convert it into the SAP-compatible format.
And you still have to physically move that data across the network, which requires protocol alignment. A protocol is just the delivery mechanism. Legacy systems might communicate using older protocols like SFTP.
Which is basically an old delivery truck.
Yes, a reliable but older truck. But modern SAP APIs expect data to arrive via modern HTTP or HTTPS protocols. Think of those as high-speed armored cars. The integration layer has to catch the package from the old delivery truck and seamlessly transfer it to the modern armored car without losing anything.
That seems like a lot of steps where something could be dropped. What happens if a translation fails midway through?
That is why you need the final layer, robust error handling. In legacy integration, data mismatches and connectivity blips happen all the time. Your error handling framework ensures that if a transaction fails, it gets logged, retried, or escalated to a human. What you absolutely cannot have is a failed transaction being silently dropped into the void, because that is how inventory gets lost or payments vanish.
So what does this all mean for the business? Why go through this architectural gymnastics? The source is very clear. This is not an IT project. It is a C-suite priority. The strategic payoff is massive. For one, operational efficiency skyrockets. When you integrate, you eliminate manual data transfer. You no longer have people manually rekeying data from spreadsheets into SAP.
Which inherently lowers the risk of human error. The guide highlights that organizations see significant reductions in their order-to-cash cycle times. That is the time it takes from a customer placing an order to the company actually having the money in the bank. When systems talk automatically, that cycle gets much faster.
It also creates data consistency. a single source of truth across the enterprise. Without it, your customer records or inventory levels slowly drift apart in the different systems, which creates massive reconciliation headaches and skyrockets your audit risk.
If we connect this to the bigger picture, the absolute most compelling strategic use case for all of this integration work is migrating to SAP S/4HANA.
S/4HANA is SAP's flagship modern system, right?
Yeah.
So how does legacy integration help you move to a brand new system?
When a massive enterprise decides to upgrade to a system like S/4HANA, the traditional old-school approach is the big bang cutover. You build the new system, turn off the old one on Friday night, turn on the new one on Monday morning, and pray it works. It is terrifying and high risk. But legacy integration allows for what is called a brownfield strategy.
So instead of tearing down the old house all at once, you're basically living in it while you build the new one, room by room.
That is the perfect analogy. You migrate in phased, controlled steps. You use these integration methods to connect the legacy systems with the new S/4HANA environment so they run in parallel. Integration essentially buys the business time. You move one department, make sure it works seamlessly with the old system still running the rest of the company, and gradually transition.
That sounds incredibly smart, but let's be real. It can't be all sunshine and perfectly mapped data fields. The guide gives us a stark reality check on the technical headaches involved. These are the specific hurdles that keep IT teams up at night. First, format mismatches. The text specifically calls out dealing with ancient EBCDIC encoding. I've never even heard of EBCDIC.
EBCDIC is a character encoding system primarily used on IBM mainframes decades ago. Think of it like a completely different digital alphabet. Most modern systems use ASCII or UTF-8. Trying to force an old EBCDIC file to play nice with SAP's highly structured, modern models requires an insane amount of custom transformation logic just to handle the translation of basic letters and numbers.
That sounds exhausting. And then you have the security gaps. The source note's older legacy systems often lack support for modern encryption standards, like TLS 1.2. How do you secure data if the system holding it literally cannot be encrypted to modern standards?
This is a major concern. When data flows across network boundaries from a highly secure SAP cloud environment into a vulnerable, unencrypted legacy box, you create an exposure gap. The integration architecture has to overcompensate. You end up building highly secure firewalls and private network tunnels around the legacy system, basically putting a bulletproof dome over it because the system itself is defenseless against modern threats.
And the most fascinating headache to me, performance bottlenecks. Wait, so the new technology is actually a threat to the old technology, just by being too fast?
You're effectively pointing a fire hose at a garden sprinkler. Modern SAP environments generate a massive, high-frequency volume of messages. Legacy systems were just not designed to process data at that velocity. So, if you aren't careful, your shiny new SAP system will blast so many messages at the mainframe that it utterly chokes the old system's CPU and memory, causing processing delays or outright crashing it.
That brings us to a big question. Looking ahead, are we going to be doing this forever? Is enterprise IT doomed to just be a constant exercise in protecting ancient garden sprinklers from modern fire hoses?
The landscape is definitely evolving. The source points toward the cloud era and makes it clear that hybrid landscapes where you mix cloud-native SAP environments with on-premise legacy systems are not a temporary stopgap. They are the new normal. We are moving toward what the industry calls the composable enterprise model.
What does a composable enterprise look like?
In a composable enterprise, legacy systems are no longer viewed as embarrassing liabilities that must be destroyed. Instead, they are treated as specialized modular components. They are basically treated as building blocks with very specific, defined API integration contracts. You don't replace the mainframe, you just wrap it in a modern API and treat it like a specialized service within your broader cloud architecture.
But how do you connect a modern public cloud system to a deeply hidden, secure, on-premise mainframe without accidentally opening that old mainframe up to hackers on the public internet?
That is where tools like SAP's Business Technology Platform, or BTP, come in. BTP features something called a cloud connector. It is almost like magic for network architects. It creates a secure, encrypted tunnel from the inside of your corporate network out to the SAP cloud. It allows communication to flow between modern cloud services and those older on-premise legacy boxes completely without exposing the old systems to the public internet. It gives you all the operational agility of the cloud while securely anchoring to your on-premise history.
So, to bring it all together, SAP legacy integration isn't just a painful IT chore. It is fundamentally about maintaining operational continuity. It is about protecting the massive financial investments an organization has made over decades while still allowing digital transformation to proceed at a safe, digestible pace. It buys the business time, eliminates manual chaos, and keeps the regulators happy.
This raises an important question, though, and it's something to ponder long after we finish today. If our current best practice strategy is to preserve these legacy systems by wrapping them in modern API layers and connecting them via advanced cloud middleware, what happens decades from now? Will today's cutting-edge cloud architectures simply become tomorrow's legacy systems? Will they just be wrapped in yet another layer of whatever future technology comes next? Are we as a society just building an endless, towering archaeological dig of enterprise software where absolutely nothing is ever truly deleted?
That is a wild thought. We're just adding layers of sediment to the digital earth, and eventually someone is going to have to dig through all of it. Well, thank you for joining us today and going down this rabbit hole. We hope this deep dive gave you a whole new perspective on the invisible digital scaffolding holding up the corporate world. Keep questioning the systems running behind the scenes of your daily life, and we will catch you on the next deep dive.
That's a wrap for today's episode of the Potenza podcast series, where we decode SAP, automate with RPA, and analyze with precision. We hope you found today's conversation insightful and inspiring. If you enjoyed the episode, make sure to like, share, and subscribe to our YouTube channel, and stay tuned for more deep dives into the technologies transforming tomorrow's enterprise. Got questions or ideas for a future episode? Drop them in the comments, we'd love to hear from you. Until next time. Thank you.